Okay. Good morning, everybody. Thank you, Justin, for the kind introduction, and thank you to TWIMS for the invitation to come and speak to you today. As Justin mentioned, I'm a co-director of TZIRI Advanced Manufacturing Technologies, where we focus mostly on training at this stage. We want to let the community know what the advantages and disadvantages of additive manufacturing are at this stage. Malika Khoja over there is the managing director of the company. So afterwards, if you want to discuss certain issues as well, you are welcome to speak to Malika as well. And then I'm also at University of Pretoria part-time, where we've just started to introduce some research in additive manufacturing. It was something that I saw was lacking at that department. We're a department of materials science and metallurgical engineering, and obviously materials are a really important part of additive manufacturing and the development thereof. Research into that is of importance as well. Okay, and as Justin mentioned as well, the fourth industrial revolution, everybody is speaking about it. It's very sexy terminology. Everyone says we must get involved with that now. And additive manufacturing over here is considered one of the pillars of the fourth industrial revolution. As you know, the other pillars are augmented reality, big data, robotics, simulation, system integration, Internet of Things, cybersecurity, cloud computing. It's all these new developments. Last month, Justin gave a brief overview of all of them, demystifying Industry 4.0. So what I'm going to do today is I'm going to focus on one of these pillars, which is the additive manufacturing one. But they are all integrated as well, which I hope I can also show you today. Okay, for those who don't have a knowledge of additive manufacturing yet, it's also called 3D printing. So as the name says, you print two-dimensional layers by layers until you have a 3D object. So you start off with a CAD-based 3D model, which you convert to an STL file that you slice into the layers that you want to print. You take it to an AM system, and at this stage there are quite a few different technologies available that can use different materials. So you print your part. After that you have to do some post-processing. That includes things like the surface finish. A lot of these additive manufacturing processes, your surface roughness isn't that great, but that can also include things like heat treatments that you have to do as well. Okay, so additive manufacturing in the news, and this is where hype is typically built up in the media. And journalists, they want to sell newspapers, they want to get a lot of online views. So to use additive manufacturing and creating a hype around it is obviously an easy way to do it. So I just had a look at some of the headlines over the past few years. So this one is from 2013, as you can see, and it said, "Get ready for the new era of global manufacturing." As you brace yourselves, we are at this point where everything is now going to change. If you read the full article, it also tells you that the way we've manufactured things are going to change. I'm pretty sure if you look at some articles before this, you will find something similar. You know, the ASTM standards committee was created in 2009. to standardize all of this. If you look at this one, this was published just a month ago, June 5th, 2019. It is additive manufacturing is about to change everything. So we're still at this point is brace yourself, it's gonna happen now. Even if you read here, it's even worse. Within a decade, 3D printing will begin to revolutionize the way companies fabricate things. So they've even made it another 10 years down the line. And this causes quite a bit of confusion in terms of, what can we really do? And what are the limitations? Why are we shifting the timeline the whole time? So having said that, is what is holding us back? Is additive manufacturing something that in future will really change the way we do things? Is it something that is growing? And the answer is yes. If you look at the market size, you can see they look at it in terms of hardware, materials, services, software, and then the total. So in 2014, it was a $4 billion industry. They are predicting this specific source, Smart Tech Publishing, they're predicting that in 2027, it will be a $40 billion industry. So that's a 10 times increase, which sounds really impressive. But let's look at it in terms of the global manufacturing industry. And you can see that 3D printing is really, really small. You can see over there, this specific source from Desktop Metal, they say in 2019, 3D printing is a $7.5 billion industry. The total manufacturing industry globally is $12 trillion. So that equates to that additive or 3D printing at this stage as a percentage of the global manufacturing industry is 0.05%. That's the reality. So the hype is there, but the reality at this stage is 3D printing is still really, really small. According to this source, let's look at 2030, which is like only 11 years from now. Now suddenly, they predict 3D printing to be a $100 billion industry. They calculated that 14 years of compounding at 20% growth. Something I want to go back to is here, 3D printing was more in isolation in relation to these other technologies, whereas in 2030 you can see that integration is shown to take place. Another important thing about this graph is 3D printing is not going to replace conventional manufacturing. Conventional manufacturing will continue. Certain things, especially simple geometries, high volumes, you will always do still with conventional manufacturing. Like the extrusion, extrusion of window frames. You're never going to 3D print that. So where we have to look at 3D printing as an opportunity is also to see how that can contribute to the other manufacturing industries to ensure that they are more financially successful. Okay, so this is from the training that we give from the Barnes Group advisors. That's not Justin Barnes, just to make that clear. The Barnes Group advisors, they are an American company. And they've created this training program in collaboration with Purdue University in America. So you can also do this training online from Purdue. At the end, I'm going to just give a bit more details about the training that we do. We've got the IP to give their training in Africa and the Middle East. And we see that as an important part of, distinguishing between hype and reality, to educate people, to give them the knowledge. So in the first course that we do is called Discover AM. We did that yesterday here at TWIMS. And they talk about the different levels of complexity. And they've got the 5 levels. So I'm just going to briefly discuss each of them and to show where the opportunities are. So the first one they call level 0 because it's pre-production. It's not proper manufacturing yet. And that's for prototyping. And that's why 3D printing has always played a big role, how it started off. And I'm not saying it's not important, but we need to develop that further to become, printing functional parts to get this in the manufacturing industry. But level 0 is prototyping, showing concepts, things like that. If you go to level 1, that's the indirect application. So that's when you print tools to make parts. So the thing that you print is not the final product. Examples of this is when you print jigs and fixtures, you print tools, tooling inserts, you print wax patterns. So that what you print, you only use to manufacture other things. Level 2 over here is when you just produce part for part. So you don't change the design, you literally take the part that is conventionally manufactured and you print it exactly as it is. Obvious examples of that would be spare parts and also parts that you can't find anymore. We had a query or an example of Porsche Classic, for instance, where the old Porsche, they couldn't get one of the parts anymore. So with reverse engineering, it was possible to print that part again. Where this can also be very useful is if a component breaks and, for instance, you are in the International Space Station, you can't quickly come back to get another part, and you can print the spare parts there. Also, if you have concerns about the supply chain, if you want to reduce the risk, if you have a supplier that then disappears, that you can go back to the original supplier so that you don't have to change the design again. These ones are the not so sexy ones. These are the ones that don't make the news really. But these are the ones where we actually have to start off with, to start making money from additive manufacturing. Level 3 is now where we start making functional parts where you design the component specifically for additive manufacturing. So you don't want to just make the part as it is already. You go and you design it to utilize the advantages that you can get from additive manufacturing. So that is for things for weight reduction, where you can reduce assembly. Where certain parts conventionally manufactured, you have got lots of parts that you have to assemble. Now you can print them as one component. Examples like that. And then level 4 is multifunctional. That's when you have a black belt in additive manufacturing. You manufacture things there where you couldn't do that with other techniques, where there's no other way of doing that. And those are the ones that you see in the news. Those are the ones where you see in the media, they print Bugatti brake calipers and they print human organs, and all these wonderful, weird things. That is of importance, obviously, but in the South African context, that's maybe not the way that we need to approach it, going directly to that type of level. And so this was a survey that was done 30 May 2019. So this is very recent, where they asked, I think they asked 1,000 professionals from different industries on how are they using additive manufacturing at this stage. So 55% of them said they're using it still for prototyping. So that's level 0 still in 2019. And that explains a lot about why this isn't going to the levels that the media set, that hype of how we're going to replace or change manufacturing forever. 43% said production. They obviously didn't say which level according to what we said, but I'm pretty confident that it's the lower levels on that graph that I showed there. Proof of concept is basically level 0. Marketing samples, level 0. Art, level 0. Education is not production. And then hobby, again, not production, that's basically level 0. So that gives us a really good overview of the industrialization of additive manufacturing that is still quite lacking. And this survey was done in America, so you would expect them to be further along with industrialization of the additive manufacturing. Then they also asked them what do they see as the benefits. Why would they use additive manufacturing? And most of them said it is for the complex geometry. So we all know that you can make very fine features, fine details. You can make internal channels. For jewelry, for instance, you can make really intricate shapes in that industry as well. 39% said lead time reduction, because you don't need to wait for the production of tooling to make some components. You just need the CAD file. Cost reduction, that's always plays a big role. Small batches, if you don't need a lot of material. It gives you the opportunity to redesign something quickly by just changing the CAD file. Mass reduction, again there we come back to the Bugatti brake caliper, and Aerospace will obviously be interested in that. Reduction of assembly steps, I mentioned earlier. There's a GE made a nozzle that they've changed from conventional to additive, and they could reduce the assembly from 20 parts to print it as 1 part only. Another engine that we discussed yesterday from GE, if I remember correctly, it went from, Malika maybe correct me, but it was something like 800 parts to 20. So that's quite a big opportunity over there. Internal channels, I'll show an example later where you can print conformal cooling channels in tooling. Tooling as well, continuous improvement in processes, and then the smaller ones, mass customization, supply chain optimization, and remote production. Okay, so this is a Gartner hype cycle. This is something that the Gartner Institute, they publish every year. This one is as of July 2018, so we've moved on a year already. That's the latest one I could find. For those who don't know the Gartner hype cycle, what it says is the expectations of a technology as a function of time. So when a technology emerges, the expectations are not that great yet. But then people start to be creative and they start dreaming, which is a nice thing about human beings. And we start seeing, imagine what we can do. And the expectations, the media, the hype, this is the hype, then increases and people get these wonderful expectations of what we're going to do. But then unfortunately reality kicks in and people get disillusioned. They see that it's not going to do all the things that they thought it could do. It's not going to change the manufacturing industry by replacing certain things. So then people get disappointed until you hit rock bottom. And the media disappears at that stage. But the people who still work in the industry, they continue with their development, they continue with their research. So then you start getting the slope of enlightenment. You start seeing, well, we can't do maybe all these wonderful things that we dreamed of, but there is still a place for this technology. And then at some stage you reach the plateau of productivity where the technology is then used in mainstream production. You can also see that the little circles have different colors, so that indicates how long they predict it will take for these different technologies on the curve to reach that plateau. So if it's white, they say it will take less than 2 years. If it's light blue, they expect it to take 2 to 5 years. Dark blue, 5 to 10 years. The triangle, more than 10 years. And in some cases, not in this one, some of the technologies become obsolete before you even reach the plateau. So some examples. Here you can see 4D printing. We're still trying to figure out 3D printing and where we're going to use it, but there's already something called 4D printing, where we add another element of time, and where you can afterwards change the shape of what you print. That is now still going up in terms of expectations, and they expect that will take more than 10 years. So in a couple of years from now, we're going to have a Gartner hype cycle curve for 4D printing. You can have one for all of these. And if I discuss each and every one here, we're going to not have a breakfast seminar, we're going to lunch and supper eventually. So I'm going to just take a couple of examples, specifically where South Africa has invested as well. For some other reason, the government decided we need to look at aerospace and biomedical to a great degree, so I'll also look at those ones. So the first one is the 3D printed tooling, jigs and fixtures. This is the level 1 production that I showed you earlier, where you print something that you use to produce your component. This is the one where I believe businesses in South Africa, manufacturers in South Africa, can gain a lot of advantages. And I'm going to show a couple of case studies. So it says there's an often overlooked additive manufacturing application where you can have potentially huge financial returns. Even so much that you don't even have to use a service bureau. You can buy your own 3D printer and get a return on investment. They state this was a market study from Stratasys, which is a well-known 3D printing machine manufacturer. And they said if you replace conventionally manufactured jigs and fixtures, you can reduce fabrication expense, you can reduce labor and speeding delivery, but the financial advantage is small when you compare it to the profit gains that you get with the production floor reductions, labor, and time to market. So what examples are there that are already being used in industry? Welding jigs, end effectors for assembly robots, soft jaws for CNC, inspection fixtures. Again, those are the ones that you won't see in the media, but those are the low-hanging fruit that you can utilize already to give you advantages over your competitors. So this is an example of CMM fixtures. These inspection fixtures, they require a lot of time, a lot of cost to machine, because they must be very accurate, they must be repeatable, they must be strong, you don't want deflections. So what this company did, this is a company, J.J. Churchill, where they inspect every blade of the jet engine turbines. So the CMM fixtures must maintain really high tolerances because it's for aerospace. And they then started to explore, can they do this using 3D printing? And they tested mark-forged onyx material. That is a nylon material with chopped carbon fibers in it. And they decided to try that to replace the conventional methods. And as you can see here, traditionally it would take 10 days to manufacture this at a cost of $1,590. With mark-forged, they could do it in 3 days and $330. So this is just one case study. I see Dave Bullock there at the back. He's here today. He's the South African distributor for mark-forged. So he can probably tell you a lot more about the case studies like this specific one. Another one is tooling, which is a potential really big market. So it's again level 1 application, because 3D printing allows you to print internal cooling channels, conformal cooling channels with geometries that you won't ever be able to do with conventional manufacturing techniques. So if you print the conformal cooling channels, you can optimize where you want the cooling to be the most at hotspots or whatever. So this is an example from SLM Solutions, a German manufacturer of powder bed fusion, laser powder bed fusion machines, and they did a case study on conformal cooling inserts in the injection molding industry. So what they wanted to look at is the cycle time without the conformal cooling channels and with the conformal cooling, optimized conformal cooling. And what they found is original without cooling, the cycle time is a minute. But with the optimized conformal cooling channels, it goes down to 14.7 seconds. And obviously, that's a huge increase in the productivity of what you do. This is already, well, not the conformal cooling channels, not really yet, but at this stage, tooling inserts for the high-pressure die casting industry are already printed in Roodepoort by Metal Hard for high-pressure die casting applications. And they've seen that they've got a lot longer tool life, which has increased their production and quality quite a bit. So this is something that is already being done. We tend to think in terms of polymers and composites mostly, but we can do the metal printing too. But as far as I'm aware of, it's only the one high-pressure die casting company that is using it at this stage here. Okay, so the next one I want to look at is the 3D printed surgical implants. As I said earlier, our government has invested quite a bit in 3D printing of implants because there's a big project, a big program on titanium to utilize. We want to utilize South Africa's vast titanium reserves, and the implants are a lot of them titanium based, so quite a bit of work has been done there. Interestingly, if we look on the Gartner hype cycle, it says that we are going to have some disappointing times ahead with the 3D printing of the implants. Also interestingly is that it is a light blue circle. So they think it's going to take 2 to 5 years to reach that plateau. So luckily this disappointment is going to happen really quickly until we get to that plateau. I don't know how many of you saw this in the news, that a University of Pretoria professor did the world's first middle ear transplant. They were on carte blanche. It was quite a big story. And as I said, this is the first time this has ever happened. Nobody else in the world did this. They 3D printed those little bones in your ear and successfully did the transplant. So it's wonderful, a really wonderful achievement. The design of the 3D printed bones that was done here in South Africa. The operation was done in South Africa, but the reality is that the printing was done in Europe, which is quite unfortunate. Disappointing in terms of that we should have been able to do that as well. This professor, luckily with the exposure that he got from government as well, I think we will have a lot more investment in terms of this in the nearby future, where we can change the medical industry for specific, highly specific, patient-specific implants. Another highly successful venture is in Bloemfontein, Central University of Technology. They've done quite a bit of these titanium implants, 3D printed implants. What makes it so valuable, or such a good technology for additive manufacturing, is you can take the MRI scan, you can take the CT scan of the patient, you can convert that into the CAD file, and you print the implant that is specific for that patient. So once it's identified that the patient needs an implant, you can do that really quickly from the CT scan up to the actual operation. So this is one of the South African success stories. There's a unit in Bloemfontein called CRPM, the Center for Rapid Product Manufacturing, where the focus is mostly on these medical implants. Okay, now aerospace and defense. I said the government is also looking at that because titanium is a very good material for aerospace and defense. And according to this, we are at this moment quite disappointed at what we can do in 3D printing in aerospace and defense. And that's mostly due to the fact that there are a lot of regulations. There's a lot of certification that you need to put components in an airplane. But if you fly and there's really bad turbulence, then you are very happy that they are making it so strict in that industry. It also shows that they think it's going to take quite a bit of time still, 5 to 10 years, before 3D printing is really taken up to a great extent in airplanes. There are components that are being printed, but they are not safety critical. So where is South Africa in this aerospace environment? We decided that we are going to build the world's largest metal 3D printer, which is really ambitious from a South African point of view. This 3D printer that you see here is an SLM 280. It's a German machine, and that's a typical size for a metal 3D printer. So the build volume over there is 280 millimeters by 280 by 300. So it's relatively small. So the components that you can build are obviously also small, and it takes quite a while. And that was the justification for Project Aeroswift at the CSIR, where they decided, let's design and build our own 3D printer, which will be the largest and fastest one in the world, and we can make big components, or we can make a lot of smaller components a lot quicker. So that was, Aeroswift was designed and built here in South Africa, and there you can see the size of this machine. So Malika is standing over there and over there to show you the size differences. And this has also been on carte blanche. It's been in the media everywhere. But the reality is Aeroswift is not producing components, safety critical components in aerospace industry yet. And if you also look in the news, they've had some legal issues lately where the different partners are not too happy with each other. So the future of this Aeroswift project is at this stage unfortunately rather unclear. They've made some interesting components. This is a 3D printed optimized UAV frame. Yeah, it's quite large, and as you can see, it's quite intricate as well. So the progress there has been good, but the future is a bit unclear of what they're going to do. Okay, so coming back to the training that I mentioned, is the best way to distinguish between hype and reality is knowledge. Is when you know what the current status is, how this process works, what you can use it for, selection of the correct processes, selection of the correct materials, and for which industries you should focus on. So, as I said earlier, we give the training of the John Barnes additive advisors, and it's not a degree. It's basically workshops containing 4 different sub courses that I will show you just now. So the whole portfolio is called Activate AM, and the 4 different courses. The first one is called Discover, then Focus, Accelerate, and Empower. If you take all 4 of them, the full portfolio, it will be a 3-day course in total. Yesterday we did the Discover AM course here at TWIMS, and that's basically the introduction. That is to teach you the basic terminology, the different processes that's available at the moment, some of the materials, and some of the real-world applications. So for this one, you don't have to be an engineer, to do this course. It's just to introduce you to the technology. The second one, Focus AM, is where we look at these things in a bit more detail now. So it says there it's an expansion upon the essentials of AM, and we look at the different processes in a lot more detail, the technical considerations. So it's Discover on steroids. Then the third one, Accelerate AM, is a design for additive manufacturing course. And that's also something that is not lacking only in South Africa, but in the world, is people do not think additive. The design engineers don't think in terms of designing for additives. They want to design the component based on their knowledge of the conventional manufacturing techniques. So what we do here is we look at that to teach them to look at the advantages, the topology optimization, the weight reductions that you can get, even biomimicry, where you can print structures that are based on structures that we find in nature. You know, we can use the millions of years of evolution that nature shows us what structures are good. And before additive manufacturing, it was not possible to do those type of structures. And then the last one, Empower AM. This is the one that will be very relevant to what TWIMS, their mandate is. This is the one to build a business case for additive manufacturing. Because it's a disruptive technology, you know, the business principles, it's quite difficult to understand where you save money and how you can use this. So this one is again not necessarily for the technical engineers. It can be for the decision makers, management, to get a good business case for where you want to use additive manufacturing. So as I said, this is, if you take all four, that will be a 3-day workshop. And the plan is hopefully to do this still in this year at TWIMS later in this year. But we will communicate the details of that for those that are interested. So in conclusion, additive manufacturing is still small. That's the reality in 2019. It's 0.06% of the global manufacturing market at this stage. But having said that, there is definitely going to be growth. This is not something that's going to go away. It's not something that's going to stay at 0.06%. This is something that will grow, but it's not something that will replace all manufacturing. The Gartner hype cycle is quite useful in this case, because it shows us the degree of maturity. It shows us how it will change over time and how the new technologies enter and other technologies mature. Then South Africa is a world leader in certain technologies and applications. As I said earlier, for South Africa to decide, let's take on the Americans, let's take on the Europeans, the Japanese, and we build our own 3D printer, and we just don't build a conventional one, let's go and build the world's largest and fastest one. That's quite an accomplishment. In our biomedical applications as well, I think that's something that we should be very proud of. And then lastly, like I said, training is essential to make sure that you know where you can use this to separate the hype from with the reality of where we are at this stage, and to look at where are the low-hanging fruit for us to utilize. Thank you.